In this video, we'll continue our discussion of the dot product, talking about what is called a directional cosine. So what a directional cosine is, consider a vector in 3 space, like to the right there. We can actually determine the angle between that vector and each axis. This could be useful in many ways. I'll let your imagination take hold there. Now, let's work. We can come up with some formulas for each one of these. This is an alpha, beta, gamma. We're trying to find those angles. So I'm going to start with just alpha. Now, recall this is the formula from this section that we're going to use. What I'm going to do is this determines the angle between two vectors. I'm going to use that to find alpha. So cosine of alpha is equal to, okay, it's going to be V dotted with, okay, it is I. And then the magnitude of V times the magnitude of I. All right, I want to remind you what I is. I is 1, 0, 0. It's a unit vector in that direction. And if I take V, and we don't know what V is, we're trying to come up with formulas. So we're going to just call V, V1, V2, and V3. So think about if I were to dot V and I, the only thing right here, if I were to dot those, the only thing that's going to come about that is V1. Everything else is going to be multiplied by 0. So we get V1 over, okay, well, the magnitude of I, well, it's a unit vector, so the magnitude is 1. So we have that if I want to find alpha, I would do V1 over the magnitude of V. Right? We can imagine what this would be like if we were to put a beta, cosine of beta is equal to, well, if that was with J, then I would have a V2 over the magnitude of V. And we got one more here, cosine of gamma is equal to V3 over the magnitude of V. And it all comes from this dot product that was up here. It all comes from here. That when I take the dot product for each one, I, J, or K, I'm only left with the component. So these are our formulas for directional cosines. Looks real bad there. Let's see if that corrects. It does not. We'll just leave it there. Okay, so those are our directional cosines. They want us to find each angle now. For that, I'm just going to do that right here. Okay, so I need to find the magnitude of U. Magnitude of U, there we go. Okay, which is the square root of 9 plus 25 plus 16. Right, that is going to be equal to, what is that? 25, 50, square root of 50. Okay, so we just run each formula now. Cosine of alpha is equal to V1, which is 3 over the square root of 50. And then if I solve for alpha by taking the inverse cosine, typing that in now. Okay, I got that alpha is about 1.1 radians. Right? We could convert that by timesing by 180, divide by pi. Alpha is, we'll write this down here. Alpha is approximately 64.9 degrees. Then I can do cosine of beta, which is going to be 5 over the square root of 50. So beta is approximately, doing the same thing, 5 there. All right, we got about 0.785 radians. So beta is about, in degrees, I times that by 180, I divide by pi. It is 45 degrees. Interesting. Okay. And then we have one more. And that one is gamma, cosine of gamma, equals -4 over the square root of 50, which tells me that gamma is approximately 2.17 rads. So that means gamma, if I times it by 180 and divide by pi, it is 124.4 degrees. All right, so that's how we find angles between a vector and each axis. It's kind of nice. Could lead into many things. I'll let your, like I said earlier, let your imagination run wild. Why we would ever need that angle.